Hello students, myself Abhishek Arora, and today we are going to discuss about the series expansion. As we have discussed in our previous videos that how to solve a particular trigonometric limit or 0 by 0 form, how we solve it, we have done it in our previous videos. Today we are just going to discuss about the series expansion. Okay, all such series expansion, whatever we are encountering here is, you need to have a look at it and you have to by heart all these series expansion, because all such series expansion will directly be will be applying into the question itself. Okay, all these series expansions, what we have considered here is, by using different theorems we have proved this. You can take any particular number, particular value of the same, you can actually check that these series are actually valid for any of the number or any value of x. Okay, so here what we are doing is, I have given all the sequences, all the series of the same. Okay, just need to have a look at all these series expansion and just by heart all these problems. Okay, after that just we need to take a illustration. Whenever we get a question that is related to your series expansion, it gets very easier by substituting all these series expansion there. Suppose that I have taken a question here, okay, that is your e power x log of 1 plus x minus 1 minus x to the power minus 2 upon x square. Okay, what I'm going to do is I'm taking the series expansion and directly applying it over here. Okay, so just substituting all these limits, that is of e power x log of 1 plus x 1 minus x to the power minus 2. Okay, all these series expansion I'm directly applying in the question. Okay, now after applying it, what I'm doing is I'm just taking x square common, okay, from the numerator and deleting it with the denominator. Now what we are left with is, that is minus 3. If we substitute x approaching 0 there, what happens? All the part get cancelled out except for minus 3. So that is the particular answer. So this is how the series expansion works. If you remember the series, you directly have to apply it and give the particular answer of the same. So next is your sandwich theorem. Sandwich theorem here, basically we are not talking about any sandwiches here. Just a sandwich theorem basically means here is, if you have a particular function that is sandwiched between any two particular functions. In this case I have taken a f of x function, a g of x function, a h of x function. Okay, a g of x function is greater than or equal to the f of x function but less than equal to the h of x function. Okay, here I am taking a consideration that the limit x approaching 0 for the first function, the answer to it is L. Okay, and the answer for the h of x function for the same limit is the same, that is equivalent to L. If this is the scenario, this is the case, then the answer of g of x at the same limit will also be equal to L. Okay, this is our basic thing to the sandwich theorem. Again, I'm taking an illustration for the same. If you see, I've taken a function that is f of x 1 minus x square by 4 and it is greater than that and less than 1 plus x square by 2. Okay, what I'm taking is, let us suppose that the first function, that is 1 minus x square by 4, it is g of x function. Okay, and 1 plus x square by 2, that is h of x function. I take the limit x approaching 0 and substitute it in both the limits. Okay, g of x and h of x. What happens? The answer to the first g of x is equivalent to 1 and h of x also gives us the same answer. Now if you read the given theorem, what happens? If the answer to f of x and g of x is the same, then the g of x will also have the same answer. F of x and h of x have same answer. You get the same answer for the g of x, which means in this case I have taken g of x, the answer of that is equivalent to 1 on a particular limit. On a particular limit, that is x approaching 0, h of x also has the same answer. That means the function f of x will have the same answer, that is at the same limit x approaching 0, you will be getting the answer that is equivalent to 1. This is your sandwich theorem. Okay. The last thing that we are going to discuss is the infinite limit. If I ask you what is 1 by 0, you always say it as infinity. Which means if I interchange my infinity with 0, okay, that is cross multiplying it, what happens? 1 by infinity will be equivalent to 0, right? The same thing is being applied in the infinite limit. Whenever we are having a function x, we just replace it by 1 by t, because x is approaching infinity. Okay, in that case x is approaching infinity. So if x approaches infinity, then 1 upon infinity will get what? That is, it will become 0. So that is how we are going to solve such problems. Okay, so again I am taking an illustration here. See, we are having a function that is 2x minus 3, 3x minus 4, 4x minus 5 and 5x minus 6, and the limit x approaching infinity. We cannot substitute limit x approaching infinity because the answer will get infinity, and we have discussed that the answer to any limit should always be a finite number, right? So how to solve such things? Just replace your x by 1 by t. Okay, if x approaches infinity, t will approach 0. Fine, I've done the same thing here. I have replaced all my x with t, 1 by t. Fine, replacing it by 1 by t, my function becomes something like this, and my limit has already changed from x approaching infinity to t approaching 0. Okay, I take the LCM, I get my final answer as 2 minus 3t, 3 minus 4t upon 4 minus 5t and 5 minus 6t. Okay, now if I substitute my t approaching 0 here, what we will be left with is 2, 3, 4 and 5, because all the part containing t will become eventually 0. So what happens? This is not a 0 by 0 form. You are only left with 2 into 3 upon 4 into 5. Okay, so that is the particular answer for the same. That is your 3 by 10 in this case. Okay, so all the infinite limits, whenever we will be solving all such kind of limits, we just have to take one thing, that is x will be equivalent to 1 by t. When x approaches infinity, t will definitely approach 0 in that case. Okay, so thank you for your viewership, and if you like the video, please subscribe and stay tuned.